So if you've seen the trailer for the video, you probably have a good concept of what the script does. You select a base grid, pick a dam template or design, you specify your tailings type, your viewpoint, and then from there you enter your starting elevation, the raise height, the freeboards, and the number of raises you'd like to apply. You give the software the location of your TSF, and then from there the script then runs a complete staging sequence. Raise the dam, deposit tailings. You're maintaining your freeboards, you're measuring the placed tailings, the pond volume, the remaining storage capacity. You create an image of the TSF after each lift, and you place all the numerical outputs into a tabulated spreadsheet that gets stored in a centralized directory. 5 raises, 10 raises, 15 raises, it doesn't matter. You fill in the specifics in the user interface and it produces a folder full of results. This video is going to be the background behind making a script like this, behind adapting it, modifying it. By the end you should understand every block in the script well enough so that you can modify it, change the deposition model, change what gets written into the spreadsheet, or add your own inputs into the user interface. More importantly, you'll learn how to generally build these types of scripts. So every Muck 3D command, function, tool that you can run from these menus, you can run from a script by leveraging the macro record feature. You can see the shortcut button right there. Also under scripts, you can run the macro record from here. So I want to transcribe the code for applying the raise dam function. For those of you not familiar with that function, first you define a generic cross-section of your dam design. Downstream slope, upstream slope, crest width. Then you link that cross-section, classified by type of facility, to a reference line. The reference line is going to be the center line of the crest at any elevation. And that's going to create a template. So I'm just going to go here, and I'm going to create a new upstream cross-section. So in your database viewer, find the dam template category. Under profiles, pick what type of facility you're working with. I'm going to go upstream. I'm going to call this cross-section test. I'm going to have a 4:1 downstream slope, 2:1 upstream slope, 25-meter crest width, and I'm going to increase my downstream and upstream shell heights such that I'm confident that I have sufficient distance from the crest to the toe that the unclipped shell that I'm going to generate always penetrates through that topography, so my slopes carry over completely. Okay, once you've defined your profile, scroll down, find the dams drop down under dam template category, and then again pick if you're working with a single profile dam, multi-profile dam, a customized user dam shell. In this case we'll just have a single profile dam, and I'm going to again create a new template now. Call it whatever you'd like, and then link that cross section to a specific center line of a crest. So I've loaded that center line layer. It's this black line in my 3D viewer, and then I'm just going to link this layer to my newly created template. Okay, so that's the process behind creating a dam template. Now I'm going to activate my macro record tool. I'm going to go into the dam templates menu, raise. I'm going to raise my dam. If you look at this interface here, you load your base grid. You select which elevation you'd like to target to create your dam to. You pick your dam template. Moving over to the discharge tab here, I have the option of creating a discharge line while also creating an unclipped dam shell, a merged grid, and all the associated line work. Okay, so I'm going to opt to create a discharge line as well. I'm going to specify a spigot spacing along that line of 100 feet, and I'm going to create this discharge line 1 foot below my crest. So if my crest is at 1580, the discharge line will be located at 1579. I'm going to hit OK. You're going to see in the scene manager, in the 3D window, the newly created layers, you have a merge grid, the grid plus dam, you have unclipped shell, all the associated line work. I'm just going to stop the macro recording now, and let's take a look at the text file that's going to generate. Okay, you can see here we ran the raise dam function. This was our base grid. We decided to create a discharge line. This was the spigot spacing along that line that was entered. This was the distance between the crest and the elevation of the discharge line. This was the crest elevation we chose, and here you can see the selected template. Okay, so if we compare this static piece of code that we generated using the macro record tool to the larger code of the full script, we can see here the raise dam piece of coding. Same structure, don't have to make any modification other than taking those static inputs of 1 foot, 1580, and replacing them with dynamic variables. So this is the workflow that I want you guys to take away. When you want to script something, do it once manually with the macro recorder on, copy that code, and then use that in your larger script. So everything you're going to see today, or most of everything, the raise dam function, the deposition run, the merge dam into grid, the create pond surface, saving the imagery, all of it is initially produced from doing it once manually in the software with that macro recorder on, and then using that piece of code. Okay, let's look at a key part of this script, the user interface. So I'm just going to run this script by drag and dropping it into the 3D window here. You'll see a user interface pop up, and we can take a look at that and the coding associated with this user interface. So this user interface is one of the few parts of this script that isn't produced from the macro record tool, but you'll have this script, and we're going to take a look at how we modify it, how you can build one for your own purposes. So you can either adapt this one or build a new one from scratch. So there are 4 fields in play here. We have get text for the project name, get floats for every number, first lift elevation, the raise height, the number of lifts, the tailings freeboard, the pond freeboard, the remaining capacity freeboard. We have a get file name for when you need to load that base grid. You'll notice as well you have a filter on the string so that only grids pop up when you go to look for that file. Then you have these get choices for the drop downs as it relates to the tailings type, the dam template, and your viewpoints. These drop downs are worth a closer look because they're dynamic variables. The get tailings names is going to reference whatever tailings types you have defined in your project. The get dam templates names is going to reference whatever dam templates you've created. And same thing with get list of viewpoints. It's going to reference whatever viewpoints you've created in your project. So everything here is specific to the project that you've created. One last detail here, the last value key equal my macro here at the bottom of the interface coding. That tells my 3D to remember whatever you entered the last time you input these fields, and you can enter last value for all fields and they will pop back up, and that's going to be a good time saver when you run similar scenarios with similar inputs over and over again, and you don't have to type in everything every time. You also have this is valid result right after the user interface coding, and that's a safeguard. Someone cancels the form, the script's going to stop cleanly instead of just continuing ahead with empty values. Okay. Okay, now let's modify this script. We're going to update the user interface. We're going to add a new field, and that field is going to give us the ability to set the discharge point spacing on our discharge lines. Okay, so if we go into our overall script here, and we go down to where the raise dam function is applied, you can see here we have a hard-coded value of 100 for the discharge point spacing. So what I'm going to do is I'm going to add a new field here below remaining capacity freeboard. So I'm going to copy this piece of code. I'm just going to add it on the next line. I'm still getting a float because it's a numerical value. I'm going to update the label here. I'm going to set a default value of 100. Make sure to add a comma at the end. Now, I'm going to add a new line here as well, where these values that you're selecting in your user interface are getting pulled out and set to variables. I'm going to add discharge underscore point underscore spacing equals result bracket and exactly this wording. So now whatever we enter in here is going to get pulled out from the results and sent to this variable discharge point spacing. Now I'm going to take this value, go back to the piece of the code where the raise dam function is applied. And now instead of having this hard-coded value of 100, it'll be whatever the variable is. I'm just going to save this. Now we can just rerun the script. You see we have a new field, discharge point spacing, do last value for all fields, update the crest elevation to 1575. Alright, something we should discuss before moving on from the top of the script here are the APIs that you can see here in this section. We're importing different functions specific to Muck and even not specific to Muck from various libraries that exist. If you macro record a function and it requires set active layer name from the muck3d.scene library, that's going to get included in the macro recording. So you don't have to both macro record and figure out what APIs you need to use. If you're using a function, that should get covered. However, for things like this user interface, we're using this ask function, the get text, get float, get file name. Those all need to be imported from the muck3d.ui.forms API. I would advise anybody, any user, to really consult the help section here of Muck3D, especially this show help in web browser. I don't know if a lot of people know about it, but it really does have a wealth of knowledge. You can see here in the user manual section, a lot of different content categorized by functionality. The command reference here I think is quite practical because it organizes the layout of the instructions of the background information identically to how it's structured here in the menus. So it's easy to find specific functions. And just getting back to the APIs here, the API reference section has all the information in regards to all the Python background as it relates to Muck3D. You can see here if I want to go into this user interface submodule, in the forms submodule I can see all the various functions that you can import. It gives you background on them, how you would use them. You can search here for specific wording. Probably be easier than going through everything. But yes, this particular help section of Muck3D, very practical, a lot of content, so that would be my first stop if I was using the software. Okay, back to our script here. Some other items that might be a little trickier that you want to take a look at here is just how we deal with the DAM templates and how they're imported. Okay, so for the tailings names, the viewpoint names, we're running a function here to import the tailings database, get all the different tailings types. We're running another function here to get all the viewpoints that have been defined within the software, and we're sending them to these variables. Okay, so at this stage, we're pulling in all the viewpoints, we're pulling in all the tailings names. It returns a list. That list gets fed into the user interface, into those drop-downs, and when you select an item from that list, it pulls out a string, the string being, the label, and then we can use that in subsequent parts in the script. For the DAM templates, when we access the DAM templates and pull them out, it doesn't return a straightforward list. It returns a container, and the first item of that container is the list that we want. So we need to add this 0 here to instruct the software, to instruct the script. We want to pull out the first item of the container, just the list. That list then gets fed into the user interface, and then when we select it from the drop down, it seems like we're selecting a string, but again, we're not selecting a string, we're selecting a list, and within that list we want to pull out the first component, and the first component is the string or the label of the DAM template that we're interested in. So we have to add this here to pull the list out of the container, and then we have to add this here to pull the string out of the list. Now I've put this check in for all 3 types in case it occurs for the other ones, but it really shouldn't. It should only occur for the DAM templates, so that's why this coding is in here and this is in here. Okay, so if you're dealing with a database, you're pulling out the values, it doesn't look quite right, it could be a similar situation. Okay, beyond that, after you've entered in the user interface, you run it, the only thing left to do at that stage is going to be to pick a point on your screen to show the area inside the TSF so the software can start simulating. When you pick a point inside the 3D window, it converts those coordinates to model space. So we don't want to use model space, we need to feed the software world space proper coordinates. So here, after you pick the point, it takes those coordinates in model space and converts them to world space. Now, this is true up till version 2026.6.6 of the software. I was just advised in subsequent releases now, so anything 2026.6.7 and on, the point you pick in the screen is going to directly get converted to world space. We don't need to convert it from model space to world space. So there's going to be 2 versions of this script. One for anything 2026.6.6 and prior, where we need to convert, and anything 2026.6.7 and after, we won't need to convert it. So the only difference will be for subsequent versions of the software, we won't need to convert it, and that will be removed from the coding. Okay, let's take a look at the engine of the script here, really, the for loop. So to begin, prior to the for loop starting, we're setting the project root to none, the image folder to none, and we're creating a blank array called volumes. Now we're saying, okay, for elevation, so for the elevation variables, in a range, or in an F range, going from start to stop in this step. So start is the first lift elevation that you enter into the user interface. Step is the raise increment or the raise height. And stop is that first lift elevation plus the raise increment times the number of raises you want to put in. And that'll be equal to that final crest elevation that you want to build towards. You are using an F range. F range does need to be imported from the APIs, from the utility API, and that is allowing you to use decimal places. If you didn't import frange, you could use range, but then you'd be working in whole numbers, and that would probably be a disadvantage, as I'm assuming you want to get to 0.5 meter crest elevations. Maybe your raise height isn't going to be a whole number every time. Okay, then coming here, we begin really the folder creation or organization of your data that you're going to produce within Muck 3D. So here you're running this new deposition run command. And at level 1 here, you're creating a folder named after whatever elevation you're at within the for loop. And the scenario name here is the folder name, which is the project name that you entered in your user interface. So whatever I enter into my user interface as the project name will become my project root folder. And then within that project root folder, or my root folder, we're going to create subfolders named after whatever elevation we're at. Okay, so I'll just quickly run the macro record for this function right here. I'm just going to activate my record. Go to Tailings, Project, New Deposition Run. I'm going to call scenario name root folder, and this can be elevation. I'll hit OK, and you'll notice within the ooze folder here, it created a new main subfolder, and within that subfolder is another subfolder, which is the working directory. If I pause the macro record here, I can see the coding identical to what I have in the main script, except I've just replaced scenario with the user interface entry for project name, and level 1 now is not just the flat word elevation, it is the string of the numerical value of the elevation that we're at. Okay, let's take a look at this piece of coding right here. This allows the script to identify the main root folder on that first iteration. So we set that project root folder to none for the first, prior to the for loop. So on that first lift elevation, prior to anything being created, there is no project root. As soon as you get into the for loop, it creates the project root. From there, it creates an images folder inside the project root and a subfolder as well for that first lift elevation. Uses that string to create a subfolder. On the subsequent run, the second crest elevation, that project root folder does now exist. It is no longer none. So now the script's going to come here. The software is going to see this piece. It's going to say, okay, it's no longer none. I don't have to worry about creating an images folder. I don't have to worry about noting this. I've already done that, and it can continue on to the raise dam function. Okay, let's take a look at the raise dam function. Again, ran it manually once with the macro record on, and then just swap out hard-coded inputs for variables. Here, the base grid now becomes the variable base underscore grid. That's going to be whatever you select in your user interface for the first crest elevation, and then on subsequent crest elevation, it's going to become the output grid from the previous crest elevation. We've added this variable here for discharge point spacing, so we can set that in the user interface. And for the height of the dam, we're going to be targeting whatever crest elevation we're at within that for loop. So initially that first crest elevation, and then whatever the value is plus the raise. The template that we're going to use is the template that we selected in the user interface. And here this discharge Z offset becomes the value of our tailings freeboard. Okay, so why does this work? When you're applying the dam template, the software is asking you, okay, relative to that crest elevation, where would you like to create your discharge line? If my freeboard value for my tailings is that offset value, I'm ensuring that I can only pour tailings up to my freeboard value. So, for example, I pick a crest elevation of 1500 for my dam. I'm going to raise the dam to 1500. I have an offset of 1 meter. for that discharge line. So now I'm creating that discharge line at 1499, 1 meter below my crest. We're using the as-drawn deposition model in this script. The as-drawn deposition model is always just going to place tailings until it reaches the elevation on the discharge line layer. So we're always ensuring in this case that we're maintaining that freeboard because we're using that as-drawn deposition model. Okay, after it's run, in the output window, the raise dam function lists the fill volume. You can see that here. We want to pull out that value that it's calculating for each crest elevation, and we want you to send that to a variable called dam fill volume. Okay. The volume here is listed with a lowercase v. The volume here in the output window has an uppercase V. So it's important that the nomenclature be specific here. If this had a uppercase V on volume, it wouldn't work. So we need to ensure we have the proper nomenclature depending on the functions we're using. For deposition models, the spelling should match. For something like the raise dam function, it won't necessarily match. So just a quick way to figure out how everything's spelled, how the software is really storing those values. Okay, so I'm going to come here and I'm going to run the raise dam function again. I'm going to record it. Okay, that's going to give me this coding. I'm just going to add to this a print result and then save it. And this is going to print in the output window how each value is actually stored by the software. I'll call this script 1. I'm going to just clear my graphics, going to clear my output window to only get fresh content. I'm going to run script 1 again. It's going to run what I just did, and then you'll notice here all of the values that it's storing as it relates to this function. It'll show you the actual nomenclature that you can use. So footprint area, for example, footprint underscore area. Volume here you can see lowercase v. So if you're using a function and you want to know exactly how the software is storing those values specifically, not necessarily how they're listing it in the output window, record and then just print it at the end. Okay, so what does it look like when you run the script from a folder creation perspective? Come here, go last value for all fields. Again, we've changed our working directory, so we have to select our base grid again, pick a point inside the TSF, and then you can see immediately project name root folder, first lift elevation subfolder. There is always a dam template subfolder that's going to get created within that crest elevation folder, and that is going to contain our grid plus dam that we're going to deposit tailings on. It's also going to contain the discharge line. Everything's going to get published to that folder named after the template that's going to be within the crest elevation folder. And it's going to continue doing that. You can see the images folder was created immediately on that first crest elevation, and the software is just going to continue to cycle through different crest elevations until it completes the final one. And then after it's completed the final crest elevation, it will publish a CSV inside this deposition 1 root folder with all the results summarized numerically and tabulated. Okay, taking a look at the code again here. So we're getting into the deposition portion. So I'm going to raise the dam to the required crest elevation, create a discharge line at the required freeboard height. We're going to pull out the volume that we needed to create that lift on top of the dam structure, and then we're going to pour some tailings. Okay, moving on to the deposition portion of the script. So we're using a single line fixed pond elevation as drawn deposition model. So this is a capacity tailings deposition model. It's going to pour tailings up until it reaches the elevation on the discharge line layer. The discharge line layer is created again when we apply that raised dam function. It is going to create a discharge layer at a distance of tailings freeboard below the crest elevation. So you're always going to be creating that discharge line at your tailings freeboard level and can only pour tailings up to that level. For the base grid, it is always going to use the grid plus dam grid that's created after you apply the raised dam function. That grid plus dam layer is always going to be in the subfolder named after the template, and this is always going to be your basis for deposition. You've placed the raise, and then you pour tailings at every single crest elevation. And you can see that in the coding here. Always go get the grid plus dam layer, use that one as our base for pouring, and it's always going to be found in a folder named after this dam grid folder variable, and that dam grid folder variable is your template select. So the script is saying go up, go find the grid plus dam. It's in a folder named after whatever our template select or selected template is called. Same thing for the discharge line, same logic. That discharge line is always going to be in that dam template subfolder, and it's always going to have the name dam discharge points, and that subfolder is going to be named after the dam template. The maximum pond elevation, or the maximum containment elevation, is our crest elevation minus 0.1, just in case there are, potentially issues with if your crest width isn't wide enough, you don't actually have containment up till the crest elevation, you might have containment slightly below it, so that's why that 0.1 is there. The pond elevation that you're targeting, or that you're designing to, is going to be the crest elevation minus your pond freeboard. That's going to ensure that your pond is always located at that freeboard level. The pond location is going to be the point you selected in the beginning after you ran your script. That's going to be set as the pond location. In, again, previous versions of the software, or the current version and previous versions of the software, it's first going to get captured as model space and then get converted to world space. For subsequent versions of the software, it's going to go straight to world space, so you won't have to worry about converting it. And again, your tailings is going to be whatever you selected in your user interface. That will be the tailings type you use. Okay, so after you run a deposition, there's going to be a variety of values that you're going to want to investigate, store, and publish to your summary table. So here we can see we're pulling out these values here, and we're sending them to different variables. So to begin, we want access to all this information here, the results in the output window of our deposition. We're going to run this get deposition result function on the results. That does need to get imported from the API, from the ooze API. Okay, that's going to store all these results here into this variable, and then from that variable now we're going to be querying specific properties. One is the total volume, and that's going to be the tailings. So this value right here. Same thing, we're going to pull out that discharge elevation, so that's going to be our maximum elevation of tailings. Then on this DEP_result, we're going to apply the getPond property function, and that's going to pull out this total volume here and the pond elevation. And we're going to store all these results in variables. So we're pulling out, every time there's a deposition, total volume of tailings place, what that discharge elevation was, what the pond volume is, and what the pond elevation is. After that, we're going to clear our graphics, And then we're going to get into a part where we're going to calculate the remaining capacity inside the TSF. Okay, so to calculate the remaining capacity inside the TSF, a pretty straightforward workflow. So first thing we're going to do is, after you've cleared your graphics, we're going to open our output grid. So I'm just going to take an output grid here. I'll just open that up. Then we're going to open the pond surface. Okay, so now we have the pond surface at our freeboard elevation, our tailings at the tailings freeboard elevation, as per what we specify. Now we want to measure the remaining capacity within here. Okay, so we currently have a pond and some tailings in here. I want to merge them together, and then I want to measure the remaining capacity from there with the tailings and supernatant pond accounted for. If we go back to our coding, we can see that's exactly what we're doing. We're opening up the output grid, we're opening up the pond surface as we just did, and then we're running this merge dam into grid function where we're going to be merging the pond surface into the output grid. Okay, so I'm just going to run that now. Grid, merge, dam into grid. Obviously, it's a pond surface, but when you're merging surfaces into grids, this is the function I would recommend using. I'm going to select my output grid. I'm going to select my surface, and it's going to create, or it's going to modify that original output grid to contain both now. And it did take that pond surface and apply the tailing style to it after it merged it in, because it is still an output grid with that style embedded in it. Okay, from there, we're just asking the software to take this new merged grid with the pond merged into the output grid with the tailings already in, and call it output grid merged. So in each elevation file, you're going to have an output grid merged item as well. You know, this could inflate the size of your project directory by having that extra grid every time. Could be something to look at maybe in terms of potentially not saving it every iteration, but I think for the purposes of this script it works well. And then to get that remaining volume, what we're calling PMF capacity here, we're going to create a pond. And that's this piece of the script here. We're creating a pond, and we're going to create a pond at the crest elevation we're currently at, minus that PMF event freeboard. So when we run the script, the value it's asking us for is the remaining capacity freeboard. So this value is, how far from the crest would you like me to measure the remaining capacity? Do you want remaining capacity, half a meter from the crest, a quarter meter from the crest, 2 feet from the crest? You'd enter that value in here. The result of that is when you create a pond at this stage, it's going to create that pond at the crest elevation minus whatever distance you entered into that user interface field. It's also going to create a pond at whatever point you selected originally after you ran the script. So all direction to the software as to where the TSF is located, or where inside the TSF is located, is consistent throughout the script. Okay, so I'm just going to create a pond. When I create a pond, just to confirm the elevation here at 1575. Okay, so I'm going to create a pond here at 1575 inside my TSF. And as I create a pond, again, that is going to be publishing a value, this time in my 3D window here of this volume. I'm going to pull out I'm going to pull out that volume, and I'm going to send it to this variable PMF capacity. I'm going to save this pond layer here as the PMF pond surface, just for the user's reference. And then I'm going to take all these values that I've stored, and I'm going to place them within that volume array that was created before the for loop. So I'm pulling out the dam raise volume, the total tailings placed, the maximum elevation of tailings, the pond elevation, the pond volume, the remaining capacity. I'm taking all those values and I'm going to place them in that array in this order. I'm again going to clear my graphics. Then I'm going to again open up the output grid, the non-merge one, the original output grid. I'm going to open up the original pond surface, the original pond outline. I'm going to go back to the viewpoint selected in the user interface, and then we're going to publish the image from that viewpoint. Again, that viewpoint that was set in the user interface. The images are all going to get published to the imagery or the images folder. The files are going to get named crest underscore whatever elevation we're at, crest-wise, and then we're going to add meters at the end. A little inconsistent with my current project that's working in feet, but that's quickly updatable within the script. After the image has been saved in the images folder with the appropriate name, I'm going to clear the graphics again, and now my base grid, instead of being whatever I selected in my user interface, after that first run, my base grid becomes the output grid. So this assures that for the next lift, I'm going to be working off of the output grid from the previous crest elevation and not just always referring back to that initial starting surface that you pick in the user interface. We're going to run this loop until we reach the end. And then this section right here is going to publish all those values to Excel. Okay, so here you can see that we are creating a CSV called tabulated values. We're putting it in the project root. If it exists, write to it. If it doesn't exist, create it. We're going to create one line header with these labels that align with the sequence that you have in your volumes array. So the label sequence here matches the sequence of how you're pulling out values or how you're listing them in that array. And then we're going to publish in each column different values from that array. So the sequence is the same. We're going to place the raise, pour tailings up to the freeboard level with a pond at the freeboard level as well, depending on what your tailings and pond freeboard entries are. It's going to extract the dam raise volume. It's going to extract the total tailings placed, the pond volume. From there, we're then going to calculate the remaining capacity by merging the output grid into the supernatant pond surface and then creating a pond on top of that at the specified PMF freeboard elevation. We're going to extract that value. We're going to take all these values, we're going to write them to the array after the for loop's complete. We're going to publish everything to an Excel file. Alright, let's take a look at doing some further modifications to the script to potentially adapt it towards your purposes. Well, the first thing I would think of here is I don't want a pond freeboard where I'm modeling to a pond elevation. I potentially just have a set pond volume that I always want to store towards. So I'm going to change this value here in my user interface. I'm going to call this pond volume. Update that unit to your cubic meters. And I'll set the default value to be, let's just say 100,000. And we'll review that for maybe a more realistic value for this particular application later. Okay, so now I have my pond volume here. Default value is 100,000. I'm going to come here and change this. So now it's going to read pond volume instead of pond freeboard. And I'm going to change this value here to pond volume. So now I have a new variable here called pond volume, and it will be the result of whatever the entered pond volume is in our user interface. Okay, so I've addressed the user interface here. That should work. Next, we're going to have to change our deposition engine. Right now, it is single line fixed elevation pond as drawn. We need single line fixed volume pond as drawn. The process, of course, is I'm going to run it once manually in the software while recording it, and then change some of the static inputs to dynamic variables. I'm going to hit record here. I'm going to go to Tailings, single line, fixed volume pond as drawn. I'm just going to load whatever values I had last. This likely won't work, but I don't need it to run successfully to get the coding. I just need it to run at all. Alright, I'm going to hit OK here. I'm still recording. I'll just pick a random spot. It did not run. My inputs were erroneous, but if I pause this now, I can see I still have the coding that I need. No APIs to import up top. I'm going to take this piece of code, go back to my main script, and I'm just going to paste this under my existing script. First thing I want to do is I want to make sure alignment of my new deposition coding here is correct. So I'm just going to tab this over, and it aligns with the previous script, or the previous portion of the script that it's overwriting. I want the same system. I'm always going to deposit on that grid plus dam that's generated after the raise. I'm always going to use that dam discharge line that's generated during the raise. So this needs to be moved down. I'm going to grab the base grid coding. I'm going to grab the discharge point coding. My fluid volume is my pond volume. I now have that new variable that I just created up top, so I'm going to use it here, pond volume. My max pond elevation, that should remain the same. I want it to be my crest elevation minus 0.1. Again, you should have containment up to your crest elevation. You should, but obviously there are cases where you won't. One case where you won't have containment up till your crest elevation is when your crest is too narrow versus your grid spacing. So in situations where your grid spacing is more than half of the width of the crest of your dam. So if you have a 20 meter wide dam crest, you would want a grid spacing of 10 meters or less. This is because when the grid resamples, your dam structure, when it resamples, where the actual structure is built on the grid, if your grid spacing is half of the crest width or less, you're definitely going to get 2 data points on top of that crest, and therefore you're going to have enough detail in the grid to have containment up to that elevation. Otherwise, your containment is going to be likely slightly below your crest elevation. To check that, I would recommend using the water tool, find maximum containment elevation. I'll just run that quickly for you now. So here's my dam. I clearly have some level of containment in here. I'm going to go water, find maximum containment elevation, just increase the tolerance a bit, and then I'm going to select the point inside the TSF. And this is going to calculate exactly where I tell you have. It's going to calculate up to what elevation you have actual containment. So you can see in this case, I've applied this dam template to 1575 feet in elevation. When I run this function, it creates the maximum pond possible, and it tells me my maximum containment elevation, the surface area of the maximum pond it can create, and the storage volume of this maximum pond. Now you can see here my maximum containment elevation is 1574.99 feet. So below what I've raised my dam to. And this is due to grid spacing versus the width of the crest on the dam. Okay, so that being said, I am going to grab this max pond elevation and I'm going to place that here. I don't need to worry about this. I don't need to worry about, how the software is iterating through different scenarios. Pond elevation. My pond elevation is going to be the guess. Right? When you're running a model with a fixed volume target, it still wants you to guess the potential elevation of the pond. So I cannot use this pond freeboard value anymore because it doesn't exist. So I'm going to use elevation, and I'm just going to say elevation minus tailings freeboard, and that should be a decent number to start iterating from. My pond location, I don't want it to be static. I want to be able to port this script from project to project, so it's going to be the point that you select on the screen after you run the script. And again, your selected tailings type should be the tailings, not a fixed tailings type. Alright, just to review here, I've grabbed both the base grid coding, the discharge point coding, maximum pond elevation, the pond elevation guess, the pond location, and the tailings type. I'm going to now remove this piece of coding that I no longer need. And now I can run a deposition model with a volume target. Okay, I'm still going to be running this get deposition result function on the results to pull the values out that populate that output window after you do a deposition run. I'm going to run this get property on it to get that total volume of tailings. I still want to run the get property to get the discharge elevation. All of that is still valid. Here in the pond height, I still want that pond elevation. In fact, I need it more than ever because I don't know what it's going to be. And in this case, the fluid volume is less necessary because I'm putting in a target. However, your volume target on your pond isn't necessarily going to be what it is. There is an error tolerance there, so it's good to pull out the actuals versus maybe your fixed target. Now I've noticed slight issue here. I have pond volume with lowercase p, lowercase v is what I'm using as my tag for the fluid volume that's actually reported. It's very similar to pond volume capital P capital V here that I'm using as my volume target that I enter into the user interface. Makes me a little uncomfortable having them so similar, so I'm going to update this value here, pond volume, and I'm going to call it actual. Just to differentiate it. Alright, so things should look pretty good now. I have to address the fact that I have this new variable named here, so I have to update it throughout the script. Alright, just continuing on with the rest of the script here. So we're going to clear our graphics, open up that output grid, open up that pond surface. None of this is changing. I want to merge them together, create that output grid underscore merged. We're going to run a pond against that merged grid that now has the tailings and the supernatant pond combined. While we create this pond at an elevation of the crest elevation minus whatever we entered in for our PMF event freeboard value, that is going to give us the remaining capacity inside the TSF. It's going to publish this pond underscore volume value to our output window. We're going to pull that out and throw that into this PMF underscore capacity variable. We're then going to save that maximum pond that can exist at that elevation under the name PMF pond surface. All of this is still current. We've updated now this blank array, or this array, which is publishing the crest elevation, dam fill volume, tailings freeboard value, total deposited tailings, the pond volume, pond height, PMF freeboard value, and the PMF capacity. So we've updated this to pond volume underscore actual to match our update here. Again, we're going to clear the graphics. None of this needs to be updated. We're going to open up that output grid again, open up a pond surface, and open up the pond outline. Okay, so I'd like to add maybe some contours, more content to our end of period imagery. So again, we are going to run it manually, save that code, and then update it as necessary. Alright, so I'm going to clear my graphics. I'm just going to make this 1575 my working directory. I want to, as closely as possible, recreate the conditions of how the script will be working, and when the script is going to be doing anything, it will most likely have that subfolder named after that crest elevation as its working directory. Okay, so things I want to add potentially to this imagery. I'm going to open up my output grid here. I'm going to turn on my record now because I want to add contours of the tailings. So I'm going to go to tailings, post-process, contour tailing surface. I'm going to go in 3-foot contours in this case. Okay, I'm not thrilled with the 3-foot contours. It seems to be not capturing anything above water here given the large increment. Luckily this is dynamic, so I'm going to just take a look at what it would look like with 1-foot contours. Alright, I'm going to live with that. I'm not crazy about the red color on them, so I'm going to go ahead and apply a style to this to make it black. I'm just going to drag and drop from my DB viewer. So when you want to style an item, applying a style from the database viewer is something that records well, and you can take that code. If you modify the color in the scene manager by right-clicking on the layer and changing at that level, it's not going to make it into the macro record. So this is a good way of stylizing things within a larger script that you may be building. Drag and drop them from the database viewer. Alright, and I'm going to stop the recording here. You'll notice up top, we've imported a function from the muck3d.scene API called setActiveLayer. This relates to just selecting layers in your scene manager, but it is a function that requires this API, which is already in our main script. Okay, so if you take a look at the coding here, we contoured the tailing surface. It's going to look in the working directory that we're in for the output grid, which is always going to exist in our case. It's going to contour at an interval of 3. We've discovered that's not sufficient. We're going to change that to 1. And it's going to create a layer called tailings contour that you can see here in our scene manager. After we've generated the contours, the default style is red. Now we can see here I selected that layer in the scene manager. That's when I changed the interval from 3 to 1 foot. That's been noted there. And then down here we're assigning the style black to it. And I'm going to maintain all of this coding. And I'm just going to grab this. And I'm going to paste it at the end of this piece here. So after it opens up the output grid, the pond surface and the pond outline, it will generate contours and make them black. Again, ensure that your alignment is correct. We can see that this should be aligning over here, and so it needs to be shifted over 1. Okay, so now I'm going to add some contours there. The viewpoint is already fairly dynamic. We could create a new viewpoint and then select it, but this is pretty much adapted to, what it needs to be. Create a viewpoint, choose it. It's fully flexible. We're going to save the imagery. Nothing here needs to change. Then we're going to clear our graphics and set it so that on the next run, the base grid becomes the output grid from the previous run. And then we're closing the loop. Our CSV needs to get updated. Or does it? We are publishing the crest elevation, dam lift volume, tailings freeboard, tailings place volume, pond height, PMF event, and PMF event capacity. So we actually did not change the sequence here. We simply updated the naming of the pond volume variable. So here everything is still in sequence. Okay, maybe we'll do further modifications in a second, but let's save this and see how we did. Alright, let's take a look at if and how this script functions. I'm going to drop my script in. Just go last value for all fields here. And I'm going to run it for 1 lift just to see what happens. So it's going to do the initial lift elevation and then do 1 beyond that. I've changed my working directory, so I need to reselect my base grid. Alright, it seems to be functioning properly. Okay, there's my much smaller 100,000 cubic meter pond now, which is the default value. I guess cubic feet, given the settings of this project. Once again, I wouldn't recommend, writing everything in your script in metric, at least in the labeling. In the project, you're working in imperial. But in principle, I think we can see what we're doing. Okay, so issue here, it contoured, it took the picture, I can see that it saved it, so everything worked at that level, but now it's asking me, am I sure I want to clear this tailings contour layer, which it colored properly, the intervals look right, but it's asking me now if I want to clear it from my 3D window. So the issue here is I did not save this tailings contour, so it's asking me if I want to save it before I clear it. And I definitely don't want to be in a situation where I have to either choose to save or discard this at every crest elevation. Okay, so that is one issue we have, and we can address that immediately. Alright, so there's 2 options here. We could save the tailings contours that we're creating, and then it wouldn't have to ask us if we're sure we want to clear it. It would already be saved, so it would just clear it. Now we already have a lot of layers that are getting saved to our specific crest elevation subfolders, so I don't want to add another thing to that. Instead, I'm just going to set it so that it doesn't ask me. See, right now, the clearing mechanism, or the clearing coding that happens after it saves the image, is set to don't ask false. I would like it to be don't ask true. So it's going to clear it and it won't ask me. Even if it isn't saved, it's just going to clear it. In fact, we should check the rest of our functions here and ensure that they're also all set to true. Check the other clear graphics functions, that is. Alright, so I'm just going to do a quick search. Clear. Graphics. There, it's true. So every instance, 3 of them in the script where we use clear graphics are all now set to true. This was the only one that wasn't, and that was an issue. Alright, I'm not saving this tailings layer, but I do kind of want to be able to set the increment on those tailings contours at the user interface level. So I'm going to add another float here that the user is going to pull in to the user interface, and that is going to dictate the tailings contour spacing later on. Now, once again, everything here is listed in meters. I know my project's in feet. Don't do this. Be consistent. But we are where we are now. There's no turning back. Okay, so I'm going to pull this value here. I'm just going to copy this coding. I'm going to go get float. I want to put this kind of later on because it is really more relating to the imagery here at the end. So I'm going to put that right over my viewpoint here. I'm going to add a get float. This is going to be called tailings contour interval in meters, theoretically. I'm going to have to pull that value out. I'm going to say tailings contour capital T capital C is going to be equal to the result bracket of this. Also note, double commas, single commas down here. Okay, so I'm going to have a new value. I'm going to pull it out. It's going to become my tailings contour. I'm going to take this, and that variable is now going to be entered into this piece of coding here where we're contouring our tailing surface. There we go. I'm going to save this. Come back to Mach 3D, which is kind of hung up on the fact that it needs still for me to approve whether or not to clear this because it's still on the previous script run. So I'm just going to discard all, and that should stop it. Let's come back here and do another test. We're going to drop our new script in. We're going to let Mach 3D help us with our errors. Line 34, we've obviously entered something in wrong here. We've forgotten a comma at the end. Alright, pretty easy fix. No comma. Don't forget your commas. Save. Run it again. Clear my graphics, just so I know where I'm at in the output window. Alright, that fixed our user interface. Let's go. Last value for all fields. We'll try deposition 3 here. We now have the tailings contour interval. I kind of know what 1 looks like, but I don't know what 0.25 is going to look like. So it's the value that's going to be easily visually identifiable if it applies correctly. I suspect it's going to ask me to reselect this base grid, so I'm going to get ahead of it and do it before it asks me. And yeah, we'll go 1, view LiDAR, and let's just run it. Alright, we'll now should reload the output grid. Pond surface, pond outline. Oh, actually, it's calculating the remaining capacity. My apologies. Okay, now it is applying the tailings contour. Alright, that's clearly denser than previously. It did not ask me if I needed to clear it. It just cleared it automatically, so both fixes seem to be working. Alright, so this seems to work. The last thing we need to do in terms of modifications, I believe we should add what the selected contour interval is to our summary spreadsheet. Okay, so we're going to need to add a new value to our volumes array. So again, prior to the loop, we create a blank array, and then within the loop, as values are being calculated, it gets published to the array here. Okay, so I want to add the tailings contour. That value is called tailings contour. I'm going to add that here. Tailings underscore contour, capital T, capital C, and it's definitely not a plus. Tailings contour. Okay, so we've added a value here. So we should be seeing whatever we select in the user interface or whatever we enter into the user interface to be published in every row of the summary spreadsheet. Okay, so I'm going to take that value here and I'm going to make sure it gets published to the Excel sheet down here. I can see here this is the labeling for the first row on that Excel sheet. I'm going to need a new label for that new column that I have. I'll just call it tailings contour interval. Again, projects in Imperial. I'm making the script in metric. It is what it is. Okay, so I have the labeling correct. Now I just need to make sure it actually publishes the value within the spreadsheet. So here I have a new item in my array. There's now a new item. I have to make space for that one. And so this will be my tailings contour interval. You can see this first one's going to be crest elevation, second one's going to be dam lift volume, so on and so forth. Okay, I now also have now a new value that I want to pull from the array here. And it's going to be D8, or the 9th item in the array, given that we're starting at 0. Okay, so you can see the structure here. This is going to be labeling on the first row. Now you're pulling values from this array up top. There's 9 different values here. 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 values here. And then you're advising within that array which value you'd like to put into each placeholder slot. And this aligns with this, aligns with the sequence here. Okay, let's run this after we save it and see if everything is in working order. Go back to our script, drop that in. We'll go deposition 4. We'll keep it at 100,000 cubes, even though it makes a very small pond. I'm going to go ahead and pick this base grid again before it asks me to reselect it. And let's run this. Okay, it's completed both crest elevations, the initial crest elevation and the subsequent one. Let's take a look at the imagery, make sure everything looks good. That looks right. That is the appropriate contour interval distance. And let's take a look at our CSV here to see if everything's getting published properly. Bring this in. Make it a little wider. That's the crest elevation. That's the dam lift volume. That's the freeboard we entered. That looks realistic. This looks realistic. This looks realistic. That is the PMF event freeboard we entered. That is the tailings contour interval we entered, and that also looks realistic. Alright, so I'm going to upload a version of this script and a little document accompanying it to help you follow along with the video, and just something in print that you can reference. The script will come in two versions. There'll be a version that's going to work with this version of the software, v2026.6.6, and previous to it, and there'll be another version of the script that works with v2026.6.7 and any subsequent release. The issue being, when you pick a point on the screen in this current version and prior to it, it registers the coordinates as model space, and we need to convert those into world space. In subsequent versions of the software, that's v2026.6.7 and beyond that, if you pick a point on your screen, it will convert it directly into world space coordinates, thus making this line of code here unnecessary. The version of the script will be our starting version, not this kind of final one that we're taking a look at now. So you can follow along with the video if you'd like and make those modifications, or just learn from those modifications and adapt the script for your own purposes. Thank you, and please continue to consult our LinkedIn page, our YouTube page, our website for any instructional content that is going to be coming out.